Hello, everyone. Welcome to my Data Camp tutorial series. I'm Professor Adam Kroom, and today we will focus on AI Fundamentals Chapter 1, Introduction to AI. Go ahead and click Start Chapter or Continue Chapter, and it'll take you to the first video, which is called Do Androids Dream of Electric Sheep? Go ahead and watch this first video, which will give you information on how to complete the next exercises. And after you've completed the video, click on next exercise. And it'll take us to the exercise called General versus Narrow AI. Some computer algorithms are capable of mimicking human intelligence to reason and solve problems on their own and to apply previously acquired knowledge on completely new types of problems. These algorithms fall into the domain of, and our possible answers are artificial narrow intelligence or artificial general intelligence. And the correct answer is general AI. Correct. However, general AI is still science fiction, while narrow AI dominates the current landscape of data science. The next exercise is called Why Python? Python is the best choice for developing machine learning solutions. Why is that the case? Possible answers: Python has a simple and beautiful syntax. Python is very versatile. Python is very flexible. Python offers rich AI-related libraries. The Python community is big and growing fast, or all of the above. The correct answer is all of the above. Python is awesome. Correct. And precisely for all of these reasons, Python's position as the top language for data science and machine learning will hardly be disputed in the near future. Press enter to continue. The next exercise is called the elephant in the room. To further illustrate the concept of narrow AI, let's see what happens when an algorithm trained for one problem is given a completely unrelated input and asked for a prediction. Specifically, what happens when you feed a picture of an elephant into a model that is trained to recognize handwritten digits? To make this simple, a digital recognition model has been pre-trained. Your task is to feed the elephant image into it and see the results. All right, so instructions. Feed the elephant underscore image into the digit underscore predictor. So I'm just gonna go ahead and copy this elephant underscore image. We'll look on the right, it says load the test example. That's already been provided for us. Next, it says apply the model on the test example. So we have test underscore digit underscore predictor. First argument is going to be elephant underscore image and submit answer. Interesting, right? Although being the pinnacle of technology, AI systems can also be easily misused and abused, even tricked, if that is the intention. Press enter to continue. Go ahead and watch this next video. All models are wrong, but some are useful. And after you've watched the video, which will give you information on how to complete the next exercises, click on next exercise, which will take you to the next exercise called parameters and hyperparameters. Let's explore the impact of hyperparameters on the performance of your model. You are building a digit recognition algorithm using the logistic regression classifier, and you are challenged to find the optimal value of its regularization parameter C. Lower values of C make the model more conservative and resilient to noise, while higher values give it more flexibility and capacity to capture the nuances. If you increase it too much, you risk overfitting. Where is the sweet spot? All right, so our instructions, it says set the value of hyperparameter C to 0.000001. Okay, so what we'll do then is up here, it says define the model, C equals to 0 dot, and then how many zeros are there? It looks like there's 5, so 1, 2, 3, 4, 5 zeros, and then a 1. All right, and Let's submit the answer. All right, cool. So we've completed instruction 1 of 4. We got 3 more to go. The next instruction is set the value of hyperparameter C to 0.0001. So we've got 3 zeros instead of 5 zeros this time. So let's go ahead and do this like we did the first one up here on the right. C equals 2, 0.123, 3 zeros, and then a 1. And let's submit that answer. Cool. And then you see down here, we're getting our results, right? So the accuracy for the first one is 59.3%. The accuracy for the next one is 89.19%. All right, so next it says set the value of hyperparameter C to 0.01. Easy, right? Just come over to the right, C equals 0.01 and submit answer. And we got an accuracy 94.59%. And finally, instruction 404, it says set the value of hyperparameter C to 100. So on the right, C equals to 100 and submit your answer. Good job. Your model was obviously over regularized in the first iteration, and increasing C gave it some slack to capture the finer variations in the data. However, increasing parameters beyond the sweet spot is not only useless, but often detrimental. Press enter to continue. All right, so the next exercise is called Too Much of a Good Thing. Let's inspect the issue of overfitting in a more visual way. Say you have measured the temperature in your office for several days and you want to create a model to describe these oscillations. You have wisely decided to tackle this challenge using a polynomial model. Your task is now to find the right value of the hyperparameter representing the degree of the polynomial. But be careful, as your measurements are quite noisy, you're in danger of overfitting if you exaggerate with model complexity. A fit underscore polynomial function has been defined for you. Instructions: set the degree of the polynomial to 1. All right, so look over on the right. It says set degree to 1, fit underscore polynomial, degree equals 2. Well, let's guess what goes in there. 1. Submit your answer. All right. And then next. So that's correct. Our next instruction is set the degree of the polynomial to 4. So you see this has changed, set degree to 4. Here, degree equals 2. Well, we put 4 in there and submit the answer. All right, great. And we have one more instruction, which is set the degree of the polynomial to 30. So on the right, just like we've set it to 1 and 4 this time, in this blank spot, we're just going to type in 30. Right? 30, boom, and boom. Submit your answer. Setting the degree of the polynomial to 1 captured the trend, but was not really impressive. Setting it to 4 looked better, but increasing to 30 did not. Lesson learned: increasing the model complexity beyond the sweet spot just makes it capture more and more noise. All right, press enter to continue. Go ahead and watch this video, 3 Flavors of Machine Learning, which will give you instructions on how to complete the next exercises. Then click next exercise, which will take you to this exercise right here. Guess the flavor 1. A model is trained based on a collection of pictures to recognize cats and dogs in pictures, annotated with appropriate labels. Into which domain does this model fall? Possible answers: this model falls into the domain of reinforcement learning, this model falls into the domain of unsupervised learning, or this model falls into the domain of supervised learning. The correct answer is this model falls into the domain of supervised learning. Yes, as the model uses labeled data, it falls into the model of supervised learning. Press enter to continue. And the next exercise is called Guess the Flavor 2. You want to apply machine learning on a large collection of news articles and cluster them into groups so that you can identify and count recurring topics while ignoring the existing news categorization. Which flavor of machine learning algorithms is the most appropriate for this task? Possible answers. Reinforcement learning is the most appropriate approach for this task. Unsupervised learning is the most appropriate approach for this task, or supervised learning is the most appropriate approach for this task. The correct answer is unsupervised learning. Yes, as you're trying to cluster data without using labels, unsupervised learning is appropriate for this task. Press enter to continue. The next exercise is called simple digit recognition. In this exercise, you want to build, train, and test the simplest digit recognition algorithm. However simple or complex the machine learning problem at hand may be, it will always contain the following steps: data loading, preparation, and splitting into the train and test partitions, model selection and training, fitting, and model performance assessment. For this purpose, you will load a data set containing 1,797 images of individual digits, 8 by 8 pixels in size. Just remember that you use regressors for predicting quantities and classifiers when dealing with categories as the outputs. Evaluate underscore predictions has been defined for you. Instructions. Select the right model to recognize digits, use linear regression if it's a regression problem, and decision tree classifier if it's a classification problem. Use .fit to fit the model using the training inputs x underscore train and training labels y underscore train. Use .predict to generate predictions on the x underscore test data frame. And finally, evaluate model performance using testing inputs, y underscore test, and testing labels, prediction underscore results. So if you look on the right, it says select the model appropriate for the task. So what we're going to do here is model equal to decision tree classifier. Boom. Train the model. So we're going to use model dot fit. X equals 2. It says right here, I'm looking right here. Yeah, so we did the first one. We used the decision tree classifiers for the classification problem. We're using .fit, and X equals to this, X underscore train. So I'll just copy and paste that there. And then Y equals 2, Y underscore train. And I'll just copy it from there and paste it right there. Next, it says generate predictions. To generate predictions, we're going to use model dot predict. And X equals 2. Right, so I'm getting this from right here. Use dot predict to generate predictions and on the X underscore test data frame. So I'll copy that and I'm going to paste that right here. And lastly, it says test the model. So Y underscore true is going to be equal to Y underscore test, right? I'm going to copy it from right here and paste it right here. And then Y underscore prediction is going to be equal to prediction underscore results. And I'll just copy and paste it right there. And submit answer. Good job. You have learned and applied the fundamental steps for creating machine learning models common to all AI projects. Press enter to continue. Good job. You have completed chapter 1, Introduction to AI. I'll go ahead and film a distinct video for chapter 2. Thank you for your attention, and I'll see you in the next video.